In the last video, we went through the problems that I circled in yellow from the Unit 2G review packet. Unit 2G, again, is all about linear systems. So today we're going to do all the rest of the problems. It's our Day 2 assignment. So when I look at number 2, it says draw a graph of a system that has one solution. Well, I think about the solutions, and the solutions I remember are the point of intersection when I have a system. So if there's one solution, that means there's one point of intersection. So in that case, if I was drawing a system that had one solution, I would have a line here, and then another line would have to have a different slope so that they would intersect. So then I could draw this line, and now this point would be the solution, so this has one solution. Looking over here, infinitely many solutions means that there's an infinite number of points where the two lines intersect. Well, there's only 3 ways we can arrange these. They can have different slopes and intersect at one point. They can have the same slope and different y-intercepts and be parallel and never intersect. Or if they have the same slope and same y-intercept, when I graph one, the other one would be graphed right on top of it. So if they have the same slope and same y-intercept, in other words, they're the same equation, they would just be graphed one right on top of another, and that's what the system would look like. Number 3 says, without solving the system, determine the number of solutions of the system. Well, so we kind of thought through these. These are our 3 options. I just want to know the number of solutions. So there's either one solution, no solution, or infinitely many solutions. So here, in order to determine this, I think it's easiest to look at the slope and the y-intercept to know what kind of picture we're going to have for the graph. So right now, this guy's in slope-intercept form. This one, however, is not. So let's take this equation and solve for y. In other words, get it into slope-intercept form. And when we do that, we get y equals a negative 2x plus 9. When I look at these two equations now, I see that this equation has a slope of 2. This one has a slope of negative 2. So one's going to be increasing, one's going to be decreasing. So it'll look like one increasing, one decreasing. That means they'll intersect at a point. So there is one solution. Scooching down here, now I actually want to solve the system by graphing. So again, I find my solutions by graphing and finding the points of intersection. So when I look at this one, I'll graph the first equation in pink. This guy's already in slope-intercept form, so I can plot the y-intercept of negative 1. I can plot the slope of negative 1 as well, down 1, right 1. And here is my line. Again, I like to have nice straight lines, plot all of these points, because it'll be important in order to see the intersection of the two lines. So here is the line that I underlined in pink. The line in blue now has a y-intercept of 5 and a slope of 2. I can think of that as 2 over 1, so I can go up 2 to the right 1 or down 2 to the left 1. And now, when I graph this, I can see the point where they intersect, and that point of intersection is this guy right here. That would be the point negative 2, comma 1. And if I want to check in my graphing calculator, there's a couple different ways I can check. So if I go to my graphing calculator, I can enter the equation in. Y equals, clear that out, negative x minus 1 and 2x plus 5. And so now when I look at this, I can either go to the table and see, go to the graph. I see the graphs here. And we talked about in class how we could calculate the intersection. So second calc, go down to intersect. There's my first curve, there's my second curve. If I guess, move the arrow closer to the intersection. And we see the point is negative 2, comma 1 is the point of intersection. Another way to do this is to look at the table. And when I look at the table, I don't see them having the same y value here. But as I scroll up here, notice that at negative 2, they both have a y coordinate of 1. So they share that point in common. Or they have that point in common, so that would be the point of intersection. So just a way you can check on there. In addition, if I think that that's the right answer, I can take this equation and I can substitute in negative 2 for x. So negative 2 minus 1, I want that to equal y, and in this case y is 1, so when I press enter, it equals 1, I'm good to go. Down here, 2 times x is a negative 2 plus 5. Now when I press enter, I want that to equal positive 1 because that's equal to y, and it does. So a few different ways I can check my answer at the graphing calculator. Moving on to here, the first equation here is x equals negative 1. That's where x is negative 1, that's right here. Now all the points that have an x coordinate of negative 1 line up right on top of one another. Or we can memorize that if it's x equals negative 1, we'll have a vertical line where x is negative 1. So here's the first line. The second line we see has a slope of 2 and a y-intercept of 3, so I plot the y-intercept and I use my slope, rise 2, run 1, or down 2 to the left 1. and I can already see where they intersect. So let's graph that line so it'll represent that entire line. And they intersect right here at this point. And that would be the point -1, 1. And again, if I want to check my answer, I can check it in the calculator. I'm going to show you this time how to check it by hand. If I check in the first equation, I substitute -1 in for x, -1 equals -1. That works. Substitute in for y. 1 equals 2 times -1 plus 3. Well, the left-hand side is simplified. The right-hand side, 2 times -1 is a -2 plus 3, or I get 1 equals 1. That works as well. So you can also check by hand if you want. Flipping to the back, moving on to number 7. Number 7 asks us to solve for y. So that means I got to get y by itself. I'm going to draw a bar. I need to get everything else to the other side. So it's y minus 32. So if I do the inverse operation and add 32 to both sides, I get 0 over here. So I'm left with y on the right-hand side, 4x plus 32. I cannot combine these because they're not like terms. This one has an x, this one does not. So my final answer, once I've solved for y, is y equals 4x plus 32. Over here it says write the equation in slope-intercept form. Well, I know slope-intercept form is y equals mx plus b, which means I got to get y by itself. So I'm going to circle y again. That's the one I want to get by itself. So I subtract x from both sides. I'm left with a -y equals -x plus 4. To get rid of that -1, it's like multiplying by -1, so I have to divide everything by -1 to get y by itself. And really that just ends up changing the sign for everything. So that is my equation when I solve for y. Scooting down to number 10, it asks us to solve the equation using any method. So we can use either substitution, elimination, or graphing. Now because they're not given graphs, I'm not going to choose graphing, we'll use substitution or elimination. When I look at these two equations, I notice that they're both in standard form. And when both equations are in standard form, often it's easiest to solve using elimination. So when I look at this, I'm going to see, can I eliminate one of the variables? Well, when I add 3x and 5x, they do not add to be 0, so they're not eliminated. But when I add -7y and positive 7y, these are these y values, or y variables, have coefficients that are opposites of one another, so they do add to be 0, so they will already eliminate. So now when I add them, I get 8x is equal to, when I add -34 plus 18, we can just type it in our calculator, -34 plus 18 is -16. Divide by 8, I get x equals -2. Now I'm not finished though, because I remember that the solution is the point where the two lines intersect, and a point has coordinates x comma y. So now I can use that to substitute into either equation. I'm going to show you that you can really substitute into both of them and get the same answer. So I'll substitute into the top one first. So that's -6 minus 7y equals -34. If I add 6 to both sides, I get -7y equals a -28. Divide by -7, I get y equals a positive 4. So I believe my solution is going to be -2, 4. Let's double check. Even if I did the other equation, I still should get the same answer, because remember that the solution is going to be a solution to both equations. So I should get the same answer no matter what. So now when I add 10 to both sides, I get 7y equals a positive 28, and when I divide, I get y equals 4. So notice, it doesn't matter which equation you substitute in for, you're still going to get the same answer as long as we didn't make an arithmetic error. I always like to check my answer, and I can do that by substituting in. So if we check our answer, 3 times x minus 7 times y, does that equal 34? Now I can do it by hand. I'm going to do it quicker in a calculator for us real quick. 3 times -2 minus 7 times 4. And when I press enter, I want that to equal -34 in order for the statement to be true, and it does. So we have -34 equals -34. We're good to go. If I check it in the other equation as well, 5 times -2 plus 7 times 4, I want to know, does that equal 18? So 5 times -2 plus 7 times 4. When I press enter, I want it to equal 18. It does. So we have 18 equals 18. We're good to go there. Scooching down here to number 12, again, I'm solving using any method I want, substitution or elimination. I look at this one and I see, well, I have a variable that's already solved for us, all by itself, so that makes it easier to do substitution usually. So if x is equal to -2y plus 5, I look to x in my other equation, and I'm going to replace it with -2y plus 5. So I'm going to rewrite that top equation, but instead of x, now I'm going to replace x with -2x plus 5, and then I'm going to finish writing that equation. From here I can solve. I first distribute. I get -4y plus 10 plus y equals 1. Because negative 4y and y are on the same side of the equal sign, or same side of the equation, I can combine like terms. And now I start doing inverse operations to solve. Divide by negative 3, divide by negative 3, I get y equals a positive 3. Again, I'm not done. I know the solution will be something comma 3, but I still need to find x. Now I can substitute into either equation just like I did the previous one. However, because x is already solved for here, this is going to be much easier to solve for x if I use this equation. So now we get that x equals negative 1. Again, I can check my answers. If I substitute in to the top one, I have 2 times negative 1 plus 3. I want to know, does that equal 1? Well, negative 2 plus 3, yep, 1 equals 1. Checking this one, I substitute 3 in for x equals negative 2 times, oh no, sorry, that was y. So negative 1 in for x, that's negative 2 times y was 3 plus 5. So that's a negative 6 plus 5, and that is equal to negative 1. So it works for that one as well. Flipping to the back, we've already done 14, so let's move to 15. Again, we can still use any method. Looking at these two equations, I see that they are both in standard form, which is an indication to me that I'd like to use elimination. Right now, if I add the x terms, these x's will not be eliminated because they don't add to be 0, nor do the y. So now I have to multiply an equation by something in order to get them to eliminate. So when I look at the 3x, I know, I'm trying to think through, what can I multiply 3 by to make it the opposite of negative 6? Well, the opposite of negative 6 is 6, so if I multiply 3 by 2, that'll be 6, and they'll add to be 0. I could also look at the y's. To make 2 the opposite of negative 4, I can multiply that by 2, and then I have a positive 4 here and a negative 4 here. Those will eliminate. So we can do either one. So let's say if we multiply the top by 2, the top equation now becomes 6x plus 4y equals 8. The bottom one, we're going to keep the same. And what I see is when I add these add to be 0, and so do these. So we have 0 equals, and on the right-hand side, these also add to be 0. Well, 0 equals 0, that means that the variables are gone, but this is a true statement. So that means there are infinitely many solutions. Another way to look at that is that if you think up here, we multiplied by 2 to eliminate them, but if I multiplied by negative 2, I would have gotten a negative 6x minus 4y equals negative 8, and we see that they're the exact same equation. And I realized that when we were graphing, when they're the exact same equation, they're one on top of another, so this would be infinitely many solutions. Infinitely many solutions. Now, if it wants to know what the solutions are, because it's saying solve, the solutions would be every point that satisfies 3x plus 2y equals 4, or that satisfies the other one because they are multiples of one another. If you say infinitely many solutions, that would be just fine. But if it's asking us to solve, really we're asking what are the solutions, and any point on that line or any point that satisfies this equation would be a solution. Scooching down here, we already did number 16, so let's move on to 17. It says Nutco is making a new nut mix in their factory. This new mix will consist of walnuts, which costs that much a pound, pistachios that cost that much. It costs them a total of this to make 45 pounds of the mixture. How many pounds of each nut are used in the mixture? Okay, so it's asking us how many pounds of each nut are used. That's going to help me figure out what we need to find. And often what we need to find is going to be what we use the variable to represent. So let's use the letters in here to make it easier. We're talking about walnuts and pistachios. Those are our two nuts. So let's let W equal how many pounds? The number of pounds of walnuts, and we'll let P equal the number of pounds of pistachios. So now when I look at this, it gives us some information. I see dollar signs with each of these, and sometimes that's an indication that those will go together in an equation. So I see walnuts cost that much, pistachios cost that much, and we spend that much money to make 45 pounds. So the first equation that we can write, I'm going to highlight in pink, that has to do with the cost. So if every pound of walnuts costs that much, then if I do 3.25 times W times the number of pounds of walnuts, that'll give me how much I spend on walnuts, plus $4.50 times the number of pounds of pistachios, and that should be my total of $177.50. That's one equation with two unknowns, so it's not enough for us to answer the question. We need to use this last piece that there's a total of 45 pounds of the mixture. So that'll be what I box in blue. So there's a total of 45 pounds of the mixture. Excuse me. That means if I combine all of the number of the pounds of pistachios and the walnuts, that'll be a total of 45. So that'll be W plus P equals 45. Okay, so now we have a system, two equations, two unknowns. We can solve the system. We just have to decide, how do you want to solve the system? We can either solve using substitution or elimination. You can solve by elimination, or think to solve using elimination because they have both in standard form. But I also have decimals here, so maybe decimals aren't as easy for some of us. If we don't like to deal with decimals and trying to multiply to get decimals or multiply by 100 to get rid of the decimals, then what we could do is use substitution. And substitution wouldn't be all that bad because in this equation we see how W and P are both have coefficients of 1, and so it makes it easier to solve for them. So I'm going to go ahead and use substitution this time. So W plus P equals 45. That means if I subtract P from both sides, W will equal 45 minus P. And now I can take W equals to that and substitute in for W into this equation. So if I rewrite that equation, that would be 3.25. I'm replacing W with 45 minus P plus 4.50P equals 177.5. So now if I multiply, I'm not quick at doing this in my head or by hand, so I'm going to just use a calculator. I multiply that, I get 146.25 minus 3.25P plus 4.50P equals 177.50. Notice that these two are on the same side of the equal sign, so I'm going to combine like terms. So I'm going to carry this down. That'll be plus 1.25P equals 177.50. And I subtract 146.25 from each side. I get 1.25P is equal to 177.5 minus my previous answer is 31.25, and now if I divide by 1.25 on each side, I get that P is equal to 25, which means that I have 25 pounds of pistachios. The question asks how many pounds of each nut were there, though, and so I also have to figure out how many pounds of walnuts. Now the walnuts, I can just take 45 minus the 25. If there's a total of 45, then I must have 20 pounds of walnuts, and you can substitute in the equation if you'd like. So 45 minus 25 gives me that W is 20. So to interpret that, how many pounds of each kind? There are 25 pounds of pistachios, and there are 20 pounds of walnuts. And there's our answer. Flipping to the back, we have one more story problem to work through. Oh, this is a long one. Let's read this. It says, Belle and the Beast recently got married and started their life together by buying a house. In order to do their laundry, they need to either buy a washer and dryer or do their laundry at laundromat. Okay, so we have two different scenarios. We have buying a washer or dryer, and I'm going to highlight everything that has to do with the washer or dryer in blue, or going to the laundromat. It costs about $400 to purchase a washer and dryer and approximately $15 a month for electricity and water to do the laundry. So that's if we buy a washer or dryer. So $400 initially, and then that much per month. If we go to the laundromat, then we go 3 times a month, and we pay $10 every time they go. All right, so then we want to write a system of equations that represents the total cost of doing laundry. We need to define variables. Well, if I look at this, my variables, if I created a graph, the x-axis I would label as the number of months, and the y-axis I would list as the total cost. So I have two scenarios. I have buying a washer and dryer, or I can go to the laundromat. So the washer and dryer are highlighted in blue. My total cost here would be $400 initially, and then $15 every month. So that would be like my y-intercept, or my starting amount, and my rate per month would be $15. So y equals my rate times x plus my 400 initially to set it up. So I'm going to box this in blue. Over here for the laundromat, I go 3 times a month and I pay $10 every time I go. Well, the first time I'd pay $10, the second time it'd be a total of $20, and the third time would be a total of $30. So I'd spend $30 a month total, which means that my rate would be $30 times however many months I go. I don't have to pay anything initially for like the startup fee or anything like that. So that would be my equation here. After how many months would it not matter which they chose? Well, it doesn't matter what they choose when the cost is the same. We can do this a couple different ways. One way that makes a lot of sense for us to do is looking at a table. Now, we can make a table quickly by using the graphing calculator and entering our equation. 15x plus 400 is one equation. The other one would be 30x. So now if I look at the table, oh, there's the graph. Let's look at the table. Table first. So negative doesn't make sense. Negative in months don't make sense. So let's go down, starting at 0. See, initially it costs more to do the laundromat. These start getting closer and closer, but it's still definitely cheaper to do the laundromat right now versus buy a washer and dryer. So if we keep going down, they start to get closer and closer. Oh, keep going. Closer, closer. Still more expensive to buy a washer and dryer, but now we're getting real close. So we see somewhere between 26 and 27 months, it changes to be cheaper or a better deal to have a washer and dryer. So we can see that between 26 and 27 months here. If we go back here, we could use the equation to get that as well. It's essentially saying when will these be equal? So 30x is equal to 15x plus 400. I see x's are on different sides of the equal sign, so I need to subtract them in order to solve for x to get them to the same side. I'm going to subtract 15 so that we have the 400 on that side and the variable on the other. So 15x equals 400. I divide by 15, I get x equals, if I go back to here, 400 divided by 15 would be 26.6 repeating, which we know is between that 26 and 27, closer to 27. So that would be 26.6 repeating, which we know is the same thing as 26 and 2/3. All right, so after how many months would it not matter which they choose? Well, in between 26 and 27 months, or I should say at 26 and 2/3 months, it would not matter which option they chose, because the costs will be the same. All right. Scooching down here, it says if they were going to live in the house for 9 years, which would be a better option for Belle and the Beast to do their laundry? Well, 9 years, I know there's 12 months in a year. So 9 years times 12 months per year. We'll convert that. 9 times 10 is 90. 9 times 2 is 18. So 90 plus 18 would be 108. 108 months. So we're really asking after 108 months, which would be a better deal. Well, we know at 26 months and 2/3, then it doesn't matter. So anything past that, we said it was a better deal for to buy the washer and dryer. If we want to check our work, we could substitute in and see the work for each. So for the washer and dryer, it'd be 15 times 108 plus 400, and 15 times 108 plus 400 is equal to $2,020. Ooh, that's a lot of money on laundry. Okay, versus here, y equals 30 times 108. If I go to the laundromat for 108 months, 30 times 108 equals $3,240. So we can see we will definitely spend more money if we go to the laundromat. So the better deal, or the better option would be buying a washer and dryer. That would be the better option. All right, and that is the rest of our review. Good luck on your test.